Okay, so this is part two of the video series on molarity. And from the part one video, you remember I was talking about making orange juice from the frozen orange juice concentrate. You know, the can of the frozen orange juice concentrate you put in a pitcher and then you fill it with 1 liter of water. So we're going to continue with that example for a few more problems before we switch over to actual molarity, because molarity is actually a measure of how many moles is in 1 liter of water. It's not actually how many cans of orange juice are in 1 liter of water. But we're going to continue with uh, this metaphor for a while so you can see how these problems are done. So, as you can see, 1 can of frozen orange juice concentrate in 1 liter of water equals a molarity of 1. And molarity is represented by a capital M. So you just put the number, in this case the number 1, and then a capital M after it. And that means a molarity of 1. And it's a molarity of 1 because there is 1 can in 1 liter of water. Because molarity always is about whatever is in 1 liter of water. This 1 liter never changes for molarity. If you want a molarity measurement, it has to be the amount of the substance, in this case the frozen orange juice, in 1 liter of water. So I'll show you what I mean in here in a minute. So if we go down to the second problem, if we have 2 cans of frozen orange juice concentrate in 1 liter of water, that means we have a molarity of 2 because there's 2 cans in 1 liter of water. If we have 3.5 cans of frozen orange juice concentrate and we put that in 1 liter of water, then we have a molarity of 3.5 or 3.5 because that's the amount of cans of frozen orange juice concentrate in 1 liter of water. Now let's look over here to the right and let's make these problems a little tiny bit more difficult, and let's figure out the molarity from them. If we have 3/4 of a can in 1 liter of water, because you like your orange juice a little bit more watery, you don't want to put a whole can in the liter of water, you just want to put 3/4 of a can. Well, in chemistry we don't deal in fractions, we deal in decimals. So we have to convert that 3/4 to 0.75 cans. So 0.75 cans in 1 liter of water, that means we have a molarity of 0.75. What about half a can if we only do half a can in 1 liter of water? Well, half is the same thing as 0.5. So 0.5 cans in 1 liter of water means there's a molarity of 0.5. What about a fourth of a can? Well, once again, we have to change a fourth into a decimal, so that's 0.25 cans in 1 liter of water. So as long as it's 1 liter of water, because remember, molarity is all about however much a substance is in 1 liter of water. This 1 liter never changes. So 0.25 cans in 1 liter of water is going to be a 0.25 molarity. Now, what if we don't have a whole liter of water in our orange juice that we're making? What if we use, like this top left example, what if we put 1 can of orange juice in, but we only put in half a liter? Well, we can't say that this has a molarity of 1 because a molarity of 1 would be 1 can in 1 liter. but we're not putting 1 liter of water in. We're only putting half a liter of water in. So again, we don't use fractions in chemistry, we use decimals. So we need to change that half a liter into 0.5 liters. But we still have 1 can in only 0.5 liters. How do we find the molarity for that? Well, the molarity is going to be the number of cans in 1 liter of water. It has to be 1 liter. So right now we only have 0.5 liters, half a liter. So what we do is if we have 1 can in 0.5 liters, we need to get this to however many cans is in 1 liter, and that's going to be your molarity. So in order to get the 0.5 liters and turn that into 1 liter, what we can do is we can divide by 0.5. We can divide by the number of liters we actually do have. So if we have 1 can and 0.5 liters, if we divide that by 0.5, and we have to do what we do on the bottom, we have to do on the top. If we divide 0.5 liters by 0.5 liters, 0.5 liters divided by 0.5 liters gives us 1 liter. So we also, what we do on the bottom, we have to do on the top. So 1 can divided by 0.5 cans is 2. So 2 cans in 1 liter. So if we have 2 cans for every 1 liter, we didn't necessarily make a whole liter of orange juice. We only made half a liter of orange juice. But if we were to have made 1 whole liter of orange juice with this recipe, 1 can for every 0.5 liters, we would have 2 cans for every 1 liter of water, which gives us a molarity of 2, because it's 2 cans in 1 liter. Now let's try the next example. We have 1 can in 3/4 of a liter. Well, we can't use fractions. In chemistry we use decimals, so that 3/4 of a liter comes out to 0.75 liters. And we have 1 can for every 0.75 liters of water. So we just need to have this 1 over 0.75, and we need to divide the top and the bottom by 0.75. So 0.75, let's do the bottom first. 0.75 divided by 0.75 is 1. So now we have 1 liter. And 1 divided by 0.75, 1 can divided by 0.75 is going to be 1.33 cans. So 1.33 cans for every 1 liter of water gives us a molarity of 1.33. Now let's go to the right-hand column and try to work these problems. In this top one, we have 2 cans for every 2 liters of water. So if we have 2 cans for every 2 liters of water, we need to turn this 2 liters into 1 liter. So if we divide by 2 on both the top and the bottom, 2 liters divided by 2 liters is 1 liter, and 2 cans divided by 2 cans is 1 can. So if the recipe is 2 cans for 2 liters of water, then for every 1 liter of water, we will have 1 can of frozen orange juice concentrate in there. And that gives us a molarity of 1 because it's 1 can in 1 liter. Now what about the next one? 2 cans in 0.5 liters of water, so half a liter of water. So if we have 2 cans in half a liter of water, 0.5, we have to divide the top and the bottom by 0.5. So let's do the bottom first. 0.5 liters divided by 0.5 liters gives us 1 liter. And 2 divided by 0.5 is going to be 4 cans. So we're going to have 4 cans for every 1 liter of water. So that is a molarity of 4. Okay, what about this last one? We only have half a can, 0.5 of a can, in 0.75 liters of water. So that's 3/4 of a liter of water. So if we only have half a can in 0.75 liters, we need to turn this 0.75 liters into 1 liter and find out how many cans that is. So if we take 0.5 over 0.75 liters and we divide the top and the bottom by 0.75, if we do the bottom first, 0.75 liters divided by 0.75 liters is 1 liter, and 0.5 cans divided by 0.75 gives us 0.67. So 0.67 cans per every 1 liter of water. So that means we have a 0.67 molarity because that's how many cans would go into 1 liter of water. Now let's take this a step further and let's understand that 1 can of the frozen orange juice concentrate is 12 ounces of that frozen orange juice concentrate. So if we look at a pitcher of orange juice with a molarity of 1, a molarity of 1 means you put in 1 can of frozen orange juice concentrate and 1 liter of water in the pitcher. So that's a molarity of 1. So if you have 1 can and 1 can equals 12 ounces of frozen orange juice concentrate, then don't you have 12 ounces of frozen orange juice concentrate for every 1 liter of water? Isn't that the logical conclusion? Because we have 1 can for every 1 liter of water. 1 can is 12 ounces, so we're going to have 12 ounces for every 1 liter of water. But let's look at this next one. What if we only have 0.75 molarity? Well, that means we're going to be using 0.75 cans of frozen orange juice concentrate in 1 liter of water. Because the 1 liter never changes. That's what molarity is. It's a measure of how much of the substance is in 1 liter of water. So if we only have 0.75 cans of frozen orange juice concentrate in 1 liter of water, and 1 whole can equals 12 ounces, well then we can take that 12 ounces in the can and we can multiply it by that 0.75 cans that we used. And 12 ounces by 0.75 is going to give us 9 ounces. So we're going to have 9 ounces in 1 liter of water if we have 1 liter of a 0.75 molarity solution of orange juice. So that would be 9 ounces that we used. Let's look at this next problem. We have a molarity of 2 this time. So a molarity of 2 means we use 2 cans in 1 liter of water. And so if 1 can is 12 ounces, we can take that times the 2 cans that we used, and that's going to give us 24 ounces of frozen orange juice concentrate in 1 liter of water. So 24 ounces is going to be how much frozen orange juice concentrate we put in 1 liter of water, because we have a molarity of 2. Now let's go to the column on the right. We have a molarity of 0.5. That's half of 1. That means we used 0.5 or half a can of frozen orange juice concentrate in 1 liter of water. So if we used half a can, we just take that times the 12 ounces per can, and that gives us 6 ounces of frozen orange juice concentrate in 1 liter of water. So a 0.5 molarity in this case means we used 6 ounces of frozen orange juice concentrate in 1 liter of water. Now what about 0.25 molarity? Well, 0.25 molarity means you used 0.25 cans in 1 liter of water. So if we take that 0.25 and times it by the 12 ounces in a can, then we're going to get 3 ounces. So in this case, with a 0.25 molarity, we used 3 ounces of frozen orange juice concentrate for every liter of water that we put in the pitcher. Okay, so let's continue with that as the problems get a little bit harder. Well, they don't get a little bit harder, they just get a little bit more like you haven't seen them before. So let's get you used to these kinds of problems. We still have 1 can of frozen orange juice concentrate equals 12 ounces. And at this first problem up here, we used half a can. We used 0.5 cans of frozen orange juice concentrate, but we only used 0.75 liters of water in the pitcher when we made this. So is this a molarity of 0.5? No, it is not, because molarity it always has to be out of 1 liter. But we don't have 1 liter here. We have 0.75 liters. So what we need to do is we need to change this to 1 whole liter. And by doing that, we can take this 0.5 cans in 0.75 liters of water, and we can divide this 0.75 liters of water by 0.75 liters of water, because 0.75 divided by 0.75 is 1. So we'll have 1 liter of water. And what we do on the bottom there, we have to do on the top. So we divide it by 0.75. We have to divide this 0.5 cans by 0.75. So 0.5 cans divided by 0.75 is 0.67. So we would use 0.67 cans for every 1 liter of water, which means this 0.5 cans and 0.75 liters of water is a molarity of 0.67. Because if you were to use a whole liter of water, you'd put 0.67 cans in there. Now what about the next one? 0.25 cans in 1.3 liters of water. Well, if we divide both the top and the bottom by 1.3, So we can get 1 liter of water. 1.3 divided by 1.3 equals 1. And what we do on the bottom, we have to do on the top. So 0.25 divided by 1.3 equals 0.19. So 0.19 cans in 1 liter of water gives you a molarity of 0.19. Now let's do the second column on the right here. We use 0.75 cans, that's 3/4 of a can, in half a liter of water. So how can we figure out what the molarity is of this? If we have 0.75 cans in 0.5 liters of water, we need to get this 0.5 liters of water into 1 whole liter of water. So if we divide both the bottom and the top by 0.5, see 0.5 liters of water divided by 0.5 liters of water gives us 1 liter of water, and 0.75 cans divided by 0.5 gives us 1.5 cans. So that means for every 1 liter of water, we used 1.5 cans of frozen orange juice concentrate, which gives us a molarity of 1.5. Now let's do the bottom one. We have 0.75 cans again, but we used 1.5 liters, 1.5 liters. So if we take the 0.75 cans over the 1.5 liters of water, we divide both the bottom and the top by 1.5. 1.5 liters of water divided by 1.5 liters of water gives us 1 liter of water. And 0.75 cans divided by 1.5 gives us 0.5 cans for every 1 liter of water. So 0.5 cans for every 1 liter of water means that our molarity is 0.5. Now let's do this backwards and let's try to find out how many ounces of the frozen orange juice concentrate we put into the pitcher of water by starting with the molarity of the orange juice that you made. So at first, let's start with this easy one up here. We have a molarity of 1. So if we have a molarity of 1, how many ounces of frozen orange juice concentrate did we put into the pitcher of water? Well, if we have a molarity of 1, that means we used 1 can in 1 liter of water. So 1 can equals 12 ounces of frozen orange juice concentrate. So that means we used 12 ounces of frozen orange juice concentrate in this 1 molarity of juice. So what about 0.19 molarity? 0.19, a molarity of 0.19. How many ounces of frozen orange juice concentrate did we put in that orange juice? Well, a molarity of 0.19 means we used 0.19 cans in 1 liter of water, because molarity always means out of 1 liter of water. This 1 does not change. 1 liter of water. So a molarity of 0.19 means 0.19 cans in 1 liter of water. So if we have 0.19 cans and each can is 12 ounces, then we need to take 0.19 cans times 12 ounces per can, and that gives us 2.28 ounces in this pitcher of orange juice that you made. Now let's do the right column. We have a 1.20 molarity. So how much frozen orange juice did we put in that water? Well, 1.20 molarity means we used 1.20 cans in 1 liter of water. So if we used 1.20 cans and it's 12 ounces per can, we're going to take the 1.20 cans times 12 ounces per can, and that gives us 14.4 ounces of frozen orange juice concentrate if the molarity is 1.20. So we have used 14.4 ounces in 1 liter of water, because molarity is all about 1 liter of water. So last one, we have a 0.64 molarity. So that means we use 0.64 cans of frozen orange juice concentrate in 1 liter of water. So if we take 0.64 cans times the 12 ounces per can, then 0.64 times 12 is 7.68. So we used 7.68 ounces of frozen orange juice concentrate for every 1 liter of water that we put in the pitcher. Okay, now I've added to this and I specified how many liters of orange juice you actually have with these measurements. So let's go up to the top left first, the 1 molarity, and the 1 molarity gave us 12 ounces of frozen orange juice. But we didn't make a whole liter of orange juice. We only made 0.5 liters of orange juice in this scenario. So we didn't use 12 ounces of frozen orange juice concentrate, because the 12 ounces of frozen orange juice concentrate was how much we would use if we were making 1 liter, putting 1 liter of water in there. But we didn't. We only put 0.5 liters of water in there. So if we take that 12 ounces that we would have used had we made a whole liter of orange juice, and we multiply it by the 0.5 liters that we actually did make, then that is going to give us only 6 ounces of frozen orange juice concentrate in 0.5 liters of water. And that's still going to be a molarity of 1, because the molarity is all about how much you used if you were to use 1 liter of water, which in this case would be 1 can of orange juice. So that's a molarity of 1, even though we didn't make a whole liter of orange juice. So we didn't need a whole can of orange juice concentrate. We only needed half a can, or 6 ounces of it. Now down here we had a molarity of 0.19, and we worked that out to be 2.28 ounces of frozen orange juice concentrate in 1 liter of water, because molarity is all about in 1 liter of water. But what if we didn't make a whole liter, put a whole liter of water in there? How much orange juice, frozen orange juice concentrate would we actually use if we were only making 0.25 liters of orange juice? So we take this 2.28 ounces of what we would use of the frozen orange juice if we were making 1 liter, and we multiply it by how many liters we actually made, which is 0.25. So 2.28 times 0.25 gives us 0.57. So we only used 0.57 ounces of frozen orange juice concentrate if we only made 0.25 liters of the orange juice solution. Now look at the right hand side. What if we made 1.5 liters of orange juice at a 1.20 molarity, which means we used 14.4 ounces of orange juice per 1 liter of water. But we didn't make 1 liter of orange juice. We didn't put 1 liter of water. We put 1.5 liters. So we're going to take that 1.5 and multiply it by the 14.4 ounces that we would use in 1 liter of orange juice. So 1.5 times 14.4 ounces is 21.6 ounces. So we're going to use 21.6 ounces of frozen orange juice concentrate if we're making 1.5 liters of it at a molarity of 1.20. Okay, last one. So we have a molarity of 0.64, which means 0.64 cans of orange juice in 1 liter of water, which comes out to 7.68 ounces for every 1 liter of water. But we didn't put 1 liter of water in there, we put 2 liters of water in there. So we take the 7.68 ounces per liter and we multiply it by the 2 liters that we made, and 7.68 times 2 is going to give us 15.36 ounces of frozen orange juice concentrate if we're making 2 liters at a 0.64 molarity, which is the concentration of the orange juice. Okay, so let's turn our attention to salt water instead of orange juice. And up here on the first example, we have a picture of 1 liter of water, and then here's my salt shaker right here. This is supposed to be table salt. And table salt is, as we know, NaCl, sodium chloride. And we used 0.75 moles of sodium chloride in a pitcher of 1 liter of water. So that's 0.75 moles of sodium chloride in 1 liter of water gives us a molarity of 0.75 sodium chloride in the solution. Because molarity isn't actually about orange juice and cans of orange juice. Molarity is about moles. It's about moles of a substance. How many moles of something like salt do you put into 1 liter of water? So the cans of orange juice was just an example to get you used to the concept. But when we're talking about molarity, we're not actually talking about cans. We're talking about moles of something. Moles of something in 1 liter of water. And again, molarity is all about the 1 liter. It's always 1 liter of water, and you find out how many moles of a substance do you put into that water to get a solution, and that's going to give you your molarity. So let's look at this problem number 2 down here, example number 2. Again, we used 0.75 moles of salt, but we only used 0.5 liters of water in this. So we have 0.75 moles of sodium chloride of salt in 0.5 liters. So is the molarity 0.75 because we use 0.75 moles? No, it is not, because we don't have 1 liter of water. because again, molarity is all about 1 liter of water. So in order to find out how many moles of salt would we put into 1 liter of water and keep this same concentration, to find out the molarity of 0.75 moles in 0.5 liters of water, we have to take that 0.75 moles in 0.5 liters of water, and we need to turn this 0.5 liters of water into 1 liter of water. And then we need to find out how many moles would go into 1 liter of water. So in order to do that, we're going to divide both the top and the bottom by 0.5, because 0.5 divided by 0.5 is 1. So that gives us 1 liter. And what we do on the bottom, we have to do on the top. So 0.75 divided by 0.5 is 1.5 moles. So we're going to have 1.5 moles of salt in 1 liter of water if we were to use that same ratio of 0.75 moles for 0.5 liters of water. We're going if we do 1 whole liter of water, we would have to increase the amount of moles up to 1.5 moles. So 1.5 moles of salt in 1 liter of water gives us a molarity of 1.5. Now, if we have up here in the first problem, then how many grams of sodium chloride is going to go into that 1 liter of water? Well, once again, we go to the periodic table for that, and we have to look up how many grams of sodium chloride is in each mole of sodium chloride. So how do we do that? Let's go to the periodic table. So if you look on your left of the periodic table, here's sodium, and sodium's atomic mass unit is 22.99. So 22.99 grams of sodium is going to equal 1 mole of sodium. Now let's look on the right side of the periodic table, and we have chlorine over here. Chlorine's atomic mass unit is 35.45. So 35.45 grams of chlorine is going to equal 1 mole of chlorine. And 1 mole of sodium chloride is 1 mole of sodium plus 1 mole of chlorine. So if we take the 22.99 grams plus the 35.45 grams, we get 58.44 grams total, which gives us 1 mole of sodium chloride. So 58.44 grams is going to equal 1 mole of sodium chloride. Let's go back to our picture now. Now I'm going to write up here at the top so we remember 58.44 grams of sodium chloride equals 1 mole of sodium chloride. So on our first example, we have a molarity of 0.75, which means we have 0.75 moles of sodium chloride in 1 liter of water. So how many grams is that? Well, we have to take our 58.44 grams per mole of sodium chloride, and if we multiply that by the 0.75 moles that we have, then 58.44 times 0.75 moles gives us 43.83 grams of sodium chloride in 1 liter of salt water with a molarity of 0.75. Now, what about this down here? What about our second problem? We have a 1.5 molarity, which means we used 1.5 moles of sodium chloride per every 1 liter of water. Well, you have to take that 58.44 grams per mole of sodium chloride and you multiply it by the 1.5 moles that we have. And so 58.44 times 1.5 moles is 87.66 grams of sodium chloride in 1 liter of water at a molarity, a concentration of 1.5.